Hello, welcome to Northern's Craft. So today we are going to talk about state function, state function, path function, and extensive and intensive properties. Properties. So let's understand by what is state function and what is path function. State function depend on state of the system. Name itself suggests. Path function depend on path of the system. As we know in thermodynamics, the universe is made up of system and surrounding. So we will now go through with it. So example of path function are work, heat, and distance traveled. State function is also called to be properties in thermodynamics. Just remember this point, okay? Properties. In state function, both extrinsic property and intrinsic property both come along in state function. State function doesn't depend on path. It depends only on state of the system. For example, if we see work, if somebody is traveling from point A to point B, so if he is taken this route or this route, if we have taken this route, then we need to do more work. If we had taken this route, we have to take less work. So work is path function. Similarly, we know that from first law of thermodynamics, del Q is equal to del W. So W and Q are equal, it shows, which implies heat is also path function. And this proves heat is also a path function. So for example, if there is a block of that thing and there is another block, if there is a single block, then heat reaches fast, but there are two blocks, it reaches slow, because heat travels through this, no? The energy difference is always there. That's why it's also a path function. Distance travel, as we see from this. Now we will see state functions example. Where is example of state function? So both extensive and intensive properties are state function. But before state function, let's understand one example of state function first. Let's consider enthalpy. Enthalpy is state function. And remember, all energies are a state function. State function we will understand from example, okay? Enthalpy. H is equal to U plus PV. Now thing is, there's two place is there. No matter what do, from where you can reach that height, always the same energy is lost. So if you see volume, no matter what you do, but it doesn't depend on path, volume also. Since we need to reach the same point, no. That's why enthalpy is that state function, and volume is also a state function, and pressure is also a state function. These things doesn't depend on the path. This depend on the state of the system, where the system is actually. Now understand what is intensive and what is extensive property. Intensive and extensive properties. Intensive properties, remark my words, depend on the amount of substance present, and extensive properties doesn't depend on amount of system thing participating. Let's take the example of some state function. state function. These both are state function, by the way, as I mentioned earlier. So if you see volume doesn't depend on how much thing is there. Now you tell me, what is electric charge? Probably you will say it is intrinsic property. No, it is extrinsic properties. Mark my words. This and magnetization both. These both are extrinsic property. It doesn't even depend on path. This both are depend on path. I mean, they doesn't have depend on the amount of substance. If you see this formula here, number of electric charge depend. Similarly, number of dipoles in magnetization. So I have mentioned about electric charge, magnetization. Now I will talk about enthalpy, mass. No, not mass. Enthalpy. Now internal energy. All energies come under this. Remember, mark my words. All energy come under extrinsic property. All energy. Okay. All energy come under extrinsic property. Whether it is entropy, enthalpy, but all specific term. Wherever specific is written, mark my words, that is intrinsic property. Like specific volume, specific enthalpy, specific entropy. These all are that intrinsic property. Now let's see some more example of intrinsic property. Density. Density is intrinsic property. Pressure is intrinsic property. Temperature is intrinsic property. Velocity is intrinsic property. Velocity, mark my words. Shit. I'm sorry. Wait for a minute. Velocity is intrinsic property. Velocity is intrinsic property. So basically, you don't need to bother about these things, but you need to remember some examples. Like, for example, in case of extrinsic property, you just remember electric charge, magnetization, volume, and all energies. Okay. And in case of intrinsic property, just remember wherever you can see all specific properties come under intrinsic property. There are some minor exceptions are there, you can remember that. And pressure, temperature, and velocity. These are intrinsic property and these are extrinsic property. So we understood from this lecture, from this small lecture, we understood state function, path function, intrinsic property, extrinsic property. And these are the basis of thermodynamics. I hope you enjoy it. Please subscribe my channel. I request it help to grow my channel. And if you have any doubt, please ask